This question asks about translational equilibrium and rotational equilibrium. Rotational equilibrium is it's focused on whether or not something is rotating. So that is a question of whether the net torque is equal to 0. If the net torque is equal to 0, then something is not going to be twisted. There's no twisting actions. Therefore, there's no rotation, and it's in rotational equilibrium. So to answer the question of whether or not something is in rotational equilibrium, you ask the question whether or not the net torque is 0. Translational equilibrium. Translation is a fancy term. I didn't emphasize it a lot early on in kinematics. It means, is something moving? Is something changing its position? Assuming these things all start at rest, that will be true. If they don't accelerate, that must mean that the net force is equal to 0. So is the net force equal to 0? And that will be true in both the x and y dimensions independently. So if the net force is equal to 0 horizontally and vertically, then an object is in translational equilibrium. If the net force is not equal to 0, then it's going to accelerate in that direction, change its position, and thereby be in translation. Okay, so translation is movement in a straight line. Rotational equilibrium, rotation is twisting. So the question, and the language is very careful. You have to be very careful about the language in these questions. It says something such as, which are only translational. I think it's best not to answer these questions, not to ask the questions and then go all and see which ones satisfy any particular question. But let's just classify each one of these first, then answer all the questions in a row, instead of asking the question and then individually trying to say yes or no for each one of these. Let's answer all questions simultaneously by classifying each one of these objects. So here's an object. There's two forces, two forces of the same magnitude. Clearly, this thing is going to be accelerating. There's a net force, and it's not going to be in translational equilibrium. But then again, if from around this pivot point, it's not twisting either. So we're going to just leave it at that. So this one is in rotational equilibrium, but it's certainly not in translational equilibrium. Let's look at this one. The same two forces are there, so we definitely know there's a net force. We know this thing's going to translate upwards. It's going to accelerate upwards and translate. And let's consider the torque. Torque is a force times a lever arm. Both of these are the same forces, but the lever arm is much longer in this direction than in this direction. So we know that the torque in the clockwise direction is much greater than the torque in the counterclockwise direction, and the way it's set up around this pivot point, this thing will rotate. So this thing will rotate. There's a net torque, and there is a net there's a net force. So this thing is not in rotational equilibrium, and it's not in translational equilibrium. Let's look at this. There's two equal and opposite forces. These two forces cannot move this object because they're equal and opposite. So this thing isn't going anywhere. But both of these are twisting in the clockwise direction, so there is a torque. So it's not in rotational equilibrium, it is in translational equilibrium. You could imagine the end result of these two forces would be to twist this thing in a straight line, and then they would just pull against each other and it would stop. But the way it is right now, it's definitely going to twist, and it's definitely not going anywhere. Let's look at this one. These forces are going to balance out this force. There's no forces pulling sideways. Vertically, these two half forces are going to balance that. But let's look at the torque. Well, this force is half as much as this one. But this is a very narrow, small lever arm here. And we can certainly see that even though this is half the size of this one, this lever arm is much more than twice the torque. So this thing is going to torque. But it's not going to go anywhere. So there's a net torque here and here. There's no net force here and here. That's what I would say. I hope I'm not wrong. These are my arguments. Try them out. Now, let's see. Here, these two forces are equal and opposite. So it's not going to translate anywhere. It's not translating certainly in this dimension, and it's not going to, so it's not translating in the perpendicular direction for sure. There's no forces at all. And in the parallel direction, these two are equal and opposite, so it's not going anywhere as far as translation goes. And let's even think about the torque. If there's a little perpendicular lever arm here for both of these forces, but it's the same for each one. This one is giving this a slight rotation this way, and this one is giving it a slight rotation that way. That's the little lever arm, the perpendicular component anyway. And those are equal and opposite, so that thing isn't, that thing's not rotating either. So this one is in rotational equilibrium because there's no net rotation, and it's translational. So I think you can now answer all of those once we think about and you can answer all of the questions based on our interpretation of these to begin with.